What if I told you there was a predator so terrifying it made the T-Rex look like a cuddly kitten? Meet Smilodon, the saber-toothed cat that outsmarted early humans and ruled the Ice Age with teeth as long as your forearm. This formidable feline was no ordinary house cat. Smilodon boasted an impressive array of physical traits that made it one of the most feared predators of its time. With saber teeth measuring up to 8 inches in length and a body size comparable to a medium-sized polar bear, this Ice Age beast was truly a force to be reckoned with. Yet despite its fearsome reputation, Smilodon remains shrouded in mystery. How did it hunt? Did it live in social groups? And what ultimately led to its extinction? These questions have puzzled scientists for decades, and the answers may challenge everything we thought we knew about prehistoric predators. As we unravel the secrets of Smilodon, we'll discover a creature far more complex and intriguing than Hollywood could ever imagine. While Smilodon's reputation as a formidable predator is now well established, its journey to scientific recognition was far from straightforward. In fact, when first discovered, this Ice Age terror was thought to be something entirely different. What led scientists to mistake a top predator for a scavenger, and how did this error change the course of paleontology? The story of Smilodon's misclassification begins over 160 years ago in the sun-baked soil of Brazil. When the first fossils were unearthed, paleontologists were faced with a puzzle. The isolated cheek teeth they found bore an uncanny resemblance to those of modern hyenas. This similarity led to a startling conclusion. They believed they had discovered an extremely large, ancient hyena. This initial judgment resulted in the creature being christened Hyena neoga, a name that would soon prove to be a misnomer of epic proportions. As more fossils emerged from the earth, including foot bones, skull material, and those iconic giant canines, scientists quickly realized their error. The creature they had uncovered was no scavenger, but a fearsome predator unlike anything seen before. With this revelation came a new name, one that would send shivers down the spines of paleontology enthusiasts for generations to come: Smilodon populator. Smilodon, meaning knife tooth, painted a vivid picture of the creature's most distinctive feature. But it was the second part of the name, populator, that truly captured the essence of this prehistoric beast. Translating to the destroyer, or he who brings devastation, it left no doubt about the lethal nature of this newly discovered predator. The reclassification of Smilodon serves as a powerful reminder of the evolving nature of paleontology. As new fossils are discovered and technologies advance, our understanding of prehistoric life is constantly being refined and sometimes completely overturned. The journey from Hyena neoga to Smilodon populator highlights the importance of fossil discoveries in correcting scientific understanding. But the story doesn't end there. As paleontologists delved deeper into the world of Smilodon, they uncovered even more surprises. The creature we now know as Smilodon actually comprises multiple species, each with its own unique characteristics. Smilodon gracilis, Smilodon fatalis, and Smilodon populator emerged as distinct branches on the saber-toothed family tree, differing in size and habitat preferences. This diversity within the Smilodon genus paints a picture of a highly adaptable predator capable of thriving in various environments across the Americas. From the forests of North America to the grasslands of South America, different Smilodon species carved out their own niches, each perfectly adapted to its surroundings. The classification journey of Smilodon also shed light on its place in the larger context of feline evolution. Scientists have now placed Smilodon within the extinct subfamily Machairodontinae, which includes all saber-toothed cats. This classification reveals an important fact. Despite often being referred to as saber-toothed tigers, Smilodons are not closely related to modern tigers at all. The initial misclassification of Smilodon as a scavenger rather than a predator serves as a cautionary tale in the world of paleontology. It highlights the challenges and complexities involved in piecing together the puzzle of prehistoric life from fragmentary evidence. Isolated findings, while valuable, can sometimes lead to incorrect conclusions when viewed out of context. From misclassified scavenger to apex predator, Smilodon's true nature was a revelation. But what made this Ice Age beast so lethal? The answer lies in a set of adaptations so specialized they allowed Smilodon to take down prey twice its size with terrifying efficiency. At the heart of Smilodon's deadly arsenal were its iconic saber teeth. These weren't just for show, they were precision instruments of predation. Unlike the serrated teeth of many carnivores, Smilodon's canines were smooth and narrow, concentrating force at their razor-sharp tips. This design allowed for catastrophic puncture wounds, capable of swiftly dispatching even the largest prey. But having impressive teeth is only part of the equation. Smilodon's jaw was equally remarkable, capable of opening up to 120 degrees, nearly double that of a human. This extraordinary gape enabled Smilodon to effectively target the vulnerable necks of large animals, delivering lethal bites with surgical precision. Interestingly, despite its fearsome appearance, Smilodon's bite force was relatively weak compared to modern big cats. Estimates suggest it could muster around 1,000 newtons of force, about 4 times weaker than a lion. However, this apparent weakness was more than compensated for by Smilodon's other physical adaptations and hunting strategy. Smilodon was built for close combat, more grappler than sprinter. Its forelimbs were extraordinarily robust, about 20% thicker than would be expected for a cat of its size. This extra muscle mass provided Smilodon with the strength to wrestle large prey to the ground and hold them in place for the killing blow. Complementing its powerful arms were Smilodon's claws, which were proportionally larger than those of modern big cats. In fact, they were twice the size of a Siberian tiger's claws, providing an unparalleled ability to grip and immobilize struggling prey. Given these physical characteristics, paleontologists believe Smilodon employed an ambush hunting strategy. It likely used its muscular build and retractable claws to pounce on unsuspecting prey, pinning them down with its powerful forelimbs. Once the victim was subdued, Smilodon could deliver a quick, lethal bite to the throat or abdomen. This hunting technique was a far cry from the prolonged chases employed by many modern predators. Instead, Smilodon relied on speed and precision over endurance. Biomechanical tests have shown that its teeth were better suited for a quick, precise bite rather than a drawn-out struggle. This aligns perfectly with a strategy of ambushing large herbivores and dispatching them swiftly. The combination of Smilodon's unique adaptations made it a highly efficient predator. Its robust limbs provided the strength to grapple with large prey, while its specialized teeth and jaw structure allowed for quick, lethal attacks. This blend of power and precision enabled Smilodon to punch well above its weight class, taking down prey much larger than itself. While Smilodon's physical prowess was undeniable, its true strength may have lain in numbers. Recent discoveries at the La Brea tar pits have shattered our preconceptions about these Ice Age predators, revealing a social structure that rivals that of modern wolves. The excavation of 2,500 individual saber-toothed cat fossils from this single location has raised intriguing questions about their behavior and lifestyle. The sheer abundance of Smilodon remains at La Brea is unusual for a predator species. Typically, in fossil records, the number of prey animals far exceeds that of predators. This anomaly has led paleontologists to consider an exciting possibility. Smilodon may have lived and hunted in social groups, much like present-day lions. Further evidence supporting this theory comes from the condition of the fossilized bones themselves. Paleontologist Chris Shaw made a groundbreaking observation. Many Smilodon fossils show signs of severe injuries that had healed over time. In the harsh world of Ice Age predators, such wounds would likely have been fatal for a solitary animal. Shaw noted, the fact that these bones healed means it had been supported in a group of saber-toothed cats. This discovery has given rise to the concept of pseudo-healthcare among Smilodon groups. The idea that these fearsome predators may have cared for their injured members challenges our understanding of prehistoric carnivore behavior. It suggests a level of social complexity previously unattributed to these ancient cats, painting a picture of creatures capable of empathy and cooperation. The implications of this social behavior are far-reaching. If Smilodon indeed lived and hunted in groups, it would have been an even more formidable force in its ecosystem. Coordinated hunting strategies could have allowed them to take down larger prey with greater efficiency, potentially giving them an edge over other predators and early human competitors. Moreover, this social structure might explain how Smilodon was able to thrive across such diverse environments. A cooperative social structure could have provided the flexibility needed to exploit different types of prey and withstand environmental challenges. The contrast between Smilodon's potential social behavior and that of modern big cats is striking. Most contemporary felines, with the notable exception of lions, are solitary creatures. This difference raises intriguing questions about the evolution of social behavior in large carnivores and the unique pressures of the Ice Age environment that may have shaped Smilodon's lifestyle. However, it's important to note that the exact nature of Smilodon's social structure remains a topic of debate among paleontologists. While the evidence from La Brea is compelling, interpreting the behavior of extinct species from fossil remains is inherently challenging. Some researchers suggest that the concentration of Smilodon fossils at La Brea could be the result of multiple individuals being trapped while attempting to feed on stuck prey rather than evidence of group living. Despite these uncertainties, the possibility of social behavior in Smilodon opens up new avenues for understanding these prehistoric predators. It challenges us to reconsider our assumptions about ancient ecosystems and the complexity of extinct species. The image of Smilodon as a lone hunter, while dramatic, may be an oversimplification of a much richer and more intricate reality. In the Ice Age, Smilodon wasn't just competing with its prey, it was also vying for dominance against other formidable predators. This prehistoric world was a stage crowded with apex hunters, each adapted to their own deadly niche. How did Smilodon survive and thrive in an ecosystem teeming with equally fearsome competitors? The answer lies in a complex web of adaptations, survival strategies, and ecological balance that allowed multiple top predators to coexist. Smilodon shared its habitat with an impressive cast of carnivores. The American lion, a close relative of modern lions but significantly larger, roamed the same territories. Dire wolves, pack hunters with powerful jaws, were also present in large numbers. These weren't the only threats. Short-faced bears, towering over modern grizzlies, added another layer of competition to this prehistoric ecosystem. At first glance, it might seem impossible for so many large predators to coexist. However, recent research has shed light on how these species managed to share their environment. Isotopic analysis of fossilized bones has revealed that Smilodon, American lions, and dire wolves had overlapping diets, suggesting they were in direct competition for food resources. This competition likely drove each species to develop unique hunting strategies and prey preferences to carve out their own niches. Smilodon's adaptability played a crucial role in its survival among such fierce competition. Fossil evidence shows that these saber-toothed cats were well adapted to a variety of biomes, including grasslands, woodlands, and forests. This versatility allowed Smilodon to thrive in diverse environments, from the northern reaches of Alberta, Canada, to the southern tip of Patagonia. By being able to hunt effectively in different terrains, Smilodon could potentially avoid direct competition with other predators in certain areas. The unique physical adaptations of Smilodon also gave it an edge in this competitive landscape. Its iconic saber teeth and powerful build made it particularly well suited for hunting large prey. While other predators like dire wolves might have focused on smaller or medium-sized animals, Smilodon could take down larger herbivores that other hunters might avoid. This specialization in large prey hunting may have reduced direct competition with some of its contemporaries. Interestingly, the presence of other large predators might have indirectly benefited Smilodon. The short-faced bear, for instance, was larger than Smilodon but had a more omnivorous diet. This dietary difference likely reduced direct competition between the two species, allowing them to coexist in the same territories without constant conflict. The relationship between these apex predators was likely complex and dynamic. While they competed for resources, Smilodon's potential social behavior, as suggested by fossil evidence from the La Brea tar pits, might have given it another advantage in this competitive environment. If Smilodon did indeed live and hunt in groups, it would have been better equipped to defend its kills against other predators and potentially take down larger prey more consistently. It's important to note that while Smilodon was a formidable predator, it wasn't necessarily dominant over its contemporaries. Each species had its own strengths and adaptations. The American lion, for instance, might have been more suited for open plain hunting, while Smilodon excelled in more closed environments where ambush tactics were effective. Despite its remarkable adaptations and ecological niche, Smilodon's reign came to an abrupt end. What could have caused the downfall of this perfectly adapted predator? The answer lies in a complex interplay of factors that turned the Ice Age world upside down. Around 10,000 years ago, the reign of Smilodon came to a mysterious and sudden end. This extinction event coincided with significant environmental changes and the disappearance of large prey species, suggesting a multifaceted collapse of the ecosystem that had supported these apex predators for millions of years. One of the most intriguing aspects of Smilodon's extinction is the potential role played by early humans. As human populations migrated into North America, they likely competed with Smilodon for similar food sources. This competition created a tense relationship between the two species, with both vying for the same limited resources in a changing landscape. The end of the last ice age brought about a warmer, drier climate that dramatically altered ecosystems across the Americas. These changes could have negatively impacted Smilodon's hunting success, as the environments they were adapted to began to shift and transform. The decline of Megafauna, the large herbivores that formed the bulk of Smilodon's prey, would have dealt a severe blow to the predator's survival prospects. Paleontologists have long debated the primary cause of Smilodon's extinction. Some argue that human competition was the driving force, with our ancestors outcompeting the saber-toothed cats for resources. Others point to the broader ecological changes and the decline of megafauna as the key factors. In reality, it was likely a combination of these pressures that ultimately led to Smilodon's downfall. Interestingly, Smilodon wasn't the only large predator to face extinction during this period. Dire wolves and the American lion also disappeared, indicating a broader ecological crisis that affected multiple apex predators. This pattern suggests that the changes occurring at the end of the Ice Age were profound enough to disrupt entire food webs and ecosystems. Some scientists suggest that a comet impact may have triggered rapid climate changes and widespread ecological disruption in North America. While this hypothesis remains controversial, it highlights the complexity of factors that may have contributed to Smilodon's extinction. Perhaps the most ironic aspect of Smilodon's extinction is that the very adaptations that made it such a successful predator may have contributed to its downfall. The saber-toothed cat's inability to adapt quickly to a landscape with fewer large herbivores proved fatal. Unlike more generalist predators that could switch to smaller prey or alternative food sources, Smilodon's extreme adaptations limited its flexibility. In a rapidly changing world, the once fearsome predator found itself increasingly out of place. Smilodon's story illustrates how even the most perfectly adapted species can struggle when faced with sudden shifts in their habitat and food sources. The legacy of Smilodon extends far beyond its fearsome reputation. This Ice Age predator's unique adaptations, potential social behavior, and role in prehistoric ecosystems challenge our understanding of extinct species. Smilodon's story serves as a cautionary tale about the consequences of specialization in a rapidly changing environment. The extinction of Smilodon prompts reflection on modern species facing similar challenges. It underscores the importance of adaptability and resilience in changing ecosystems, offering valuable insights for current conservation efforts. As we grapple with contemporary environmental issues, the rise and fall of Smilodon remind us of the delicate balance in nature and the potential consequences of rapid ecological change. The saber-toothed cat's legacy continues to inspire scientific inquiry and shape our understanding of prehistoric life, extinction events, and the intricate web of life on Earth.